In this video, we'll take a look at this cheap 1U server from Aliexpress. There are loads of devices like this available at very reasonable prices, and on the surface they look like the perfect hardware for building a router around software such as PFSense, VyOS, OPNSense, or a bare OS such as FreeBSD or Linux. This particular model I have is from a seller called Shenzhen Heichang IPC Technology Co Limited, or HCIPC for short. I apologise if I've completely butchered that name. It has an Intel Celeron C1037U CPU, 4GB of RAM and a 64GB SSD. It also has 6 Intel gigabit NICs, which should make it perfect for use as a router. This model in this configuration costs £185.49 or £225.50 when you factor in basic shipping. I actually got mine for £218.42 because I initially ordered an Atom D2550 based model that was out of stock. So the seller contacted me and the option was either to downgrade to an Atom D525 or upgrade to the Celeron model at a slight discount, which they claimed was cost price. I don't know if it really was, but that's what they said. Obviously bear in mind these prices may be subject to change due to exchange rates because it's coming from China, so they'll be setting it based on probably their exchange rate to your local currency, or maybe go through dollars, so prices are subject to fluctuations. There's a huge selection of these machines from various different sellers, ranging from Atom CPUs all the way up to desktop i5 and i7s, and also you could put Xeons in there as well. When buying these machines, you have two options. You can buy the bare bones, which won't include RAM or storage. If it has a soldered CPU, you will get the CPU, but if it has a socketed CPU, you won't get a CPU and you'll have to supply your own. Alternatively, you can buy the machine as what they call a system, which includes RAM, storage and a CPU, which is what I've done here. Similar machines are also available in desktop form factor rather than the rack mount one I have here. Also, a quick word on shipping. I ordered mine using the cheapest EEMS option for £40. However, the seller contacted me and said they couldn't use this because the device included a battery, and instead they were going to ship it with DHL, free of charge. They didn't charge me any extra for that, despite the DHL option costing £160 on the listing, which is pretty good. So, if you're thinking about buying one of these and don't need it super urgently, you may want to just try getting the cheapest shipping option and see if they upgrade you to DHL, because that was pretty good and I didn't have to pay any extra. So now let's take a look at the machine, see how it runs, take it apart and see how well built it is, and then we'll sort of see how well it works as a router. So now let's take a look at what you get. So the router came in a proper box with like proper foam inserts, so it was really well packaged, which was good, and this is what you get. Obviously you get the machine itself, which we'll look at in a lot more detail later, but then you get these two little bags of accessories we'll take a look at now. So you first of all get this little one here, which, if I get into here, they're very generous. They give you a whole 2 cable ties, just in case you need them. You then get a little phone stand branded with the company's logo. They tend to do this, these sellers, they'll give you like what they call a gift with the thing, so you get a little sort of phone stand. I've not used it. Oh, it does that. It's also like one of the sort of snap band things that attaches to the back of a phone. So yeah, you get that with it. You then get a business card for the person, well, this is the person I was actually talking to on Aliexpress when I was buying it. So I don't know if this is like, you know, your account manager or something essentially, and this is, you get their business card. But yeah, it's a business card of someone at the company. It's not really exciting. And you get this, which is pretty amusing. You get a little sort of card saying like, leave them good feedback and all that sort of stuff that you get with all these sellers, with little cartoon characters on the front. Then on the back, which is pretty amusing, you get this sort of little story. So you get Journey to the West. You get like a little sort of ancient Chinese classical novel, and somehow that translates to buying a server on AliExpress with little cartoon characters. And that guy there looks way happier than the DHL guy that delivered it to me, but yeah, pretty amusing. You get these things with all these parcels. Now let's take a look at the more useful accessories which come in this bag. So what you get a driver's disc. I personally probably wouldn't really trust this, I don't know. I did actually put it into a Linux box and test it, you know, a pretty disposable machine essentially. And it did have drivers on it for this machine, but also had it for all their machines, so I think it's essentially just a generic disk they can distribute with any machine they sell. There was nothing that special, it was all just standard Intel drivers, so I would probably just download them from Intel's site, but yeah, you get that if you do actually trust it. Then you get SATA cable, little bag of screws for mounting drives, which we'll take a look at when we're inside, and then a couple other cables we'll take a look at once we've actually taken it apart. So let's get all that cleared up and take a look at the hardware. So now here we are looking at the device. It's actually pretty well made. It feels really sturdy and quite heavy. It's not flimsy like a cheap PC case would be, so it actually feels fairly reasonable. Over here we can see we have their logo, HCIPC, with some Chinese writing underneath. I presume that's just their name in Chinese. And over here it says full gigabit multi-WAN router, which is actually one of the most least ridiculous things I've seen on one of these. There's another seller that sells it that says network intelligence expert on it, I think. And then I saw another one that was pretty amusing, that they tried to label the ports using the Linux ETH0 through ETH whatever it had numbering, so it was like ETH0, ETH1 and so on, but they spelt it EHT rather than ETH. And on the same machine it had SFP ports that they'd labelled FSP ports. So yeah, this one actually had probably the least ridiculous things on the front. But now we can take a look at the ports. So over here you see you have two switches, you have a reset switch and a power switch. These are actually recessed into the machine, so you need to poke something in to press those. However, it switches on automatically when it's given mains power or using the main switch at the back, so you shouldn't really need these that often, so they're sort of recessed. You get a standard RJ45 console port, so that's just a serial port you could use. A pair of USB ports, they're just USB 2, but it doesn't really matter. A pair of LEDs, you get the power indicator and disk activity indicator. And then 6 Intel Gigabit Ethernet ports with integrated LEDs. And they're labelled LAN 1 through LAN 6. It's one of those things, they should have just left them blank because, you know, they don't need to label these. It's like, one of these isn't going to be a LAN port, so don't write LAN on it. But yeah, you can just obviously ignore the labelling. It would be nice if they left that blank, but oh well, they always put stupid things on the front of these. But yeah, that's what you get on the front. Now if we take a look around the side, you can see we have some just ventilation, a couple of screws to hold the side on, so nothing that fancy. The other side's just the same. And then on the back, we can see it's a bit more interesting. We get a standard VGA port, a pair of 40mm fans, and a power input. This is a standard IEC connector with a rocker switch that actually contains a built-in neon indicator for some reason, and also has a little fuse holder that you can pull the fuse out, and it contains just a little simple glass fuse. Just really additional protection, it's nothing that exciting, but yeah, you get a little fuse holder in there as well. And that just pops in. And even this bit feels reasonably good quality, so yeah, pretty happy with that. So now let's fire this up and see it running. So we'll just switch power on at the back. So that beeping noise seems to be the post beep. It seems to beep different number of times depending on how many devices you have connected. So if you plug in multiple USB devices, you get extra beeps. It just seems to be what it does when it initializes. But the main thing you'll notice is the fans are actually quite loud, the built-in ones. They are pushing a fair bit of air out the back, but yeah, they're a bit too loud really for me to be using in this current configuration. However, what I'm going to do to solve that is I'm going to install these two 40mm Noctua fans. I had these spare, so we'll install these and we'll see what it does to the temperatures. Hopefully it won't cause them to get too high having these fans rather than the higher pressure, the ones that are in it, because these are quite wimpy fans. But yeah, we'll do some tests, we'll see how much changing the fans affects temperature. We'll even see what it's like without the fans at all. It might actually be okay. But yeah, it's booting up there. That absolutely horrific noise is what it does when PFSense starts. I think PFSense tries to play a little tune to say it's on, and the speaker in this can't quite do that tune, and it makes that horrific screech. But yeah, fans are a little bit loud, but when we take it apart, we'll replace those with these Noctuas and see what it sounds like then, and hopefully the temperatures will be okay. So now let's take a look at the power consumption, which is pretty important for a device like this. So here you can see it sitting at idle on the Windows desktop, and it's pulling between 19 and 20 watts. So that's really good. So at idle it barely even pulls 20 watts. And now here you can see it running a full Prime 95 stress test, and if looking at the results here, it's pulling between 28 and 29 watts. So that's really pretty impressive power consumption. So even under full CPU load, it still pulls under 30 watts, which is actually pretty impressive. Okay, so now let's take this thing to bits and see what it's like inside. I'm quite interested to see what's in here, to see how well built it is for such a cheap device. So it's fairly easy to take apart. There's two screws on each side and one on the back. So we'll just take those out and pop the top off. So now that all those screws are removed, let's take the top off. So it should probably just slide back from here, maybe lift up a little bit. Yeah, just pull that off. there we go. So the top's now released, let's see inside. Oh, just caught a little bit there. There we go. And this is actually really thick. I'm really impressed. Like, it's way thicker than even some sort of mid-range PC cases I've used. Like, it's actually pretty good. I suppose it has to be for a rack mount case because it's sort of being suspended from both sides, and the strength of like the rest of the case is basically what holds the whole thing together. But yeah, this is actually pretty decent metal, so pretty impressed. And it's all sort of powder coated with this black stuff, which is actually feels fairly durable. So it's, yeah, pretty nice actually. So now here we can see the general layout of the inside of the machine. So over here we have the motherboard, which is a fairly nice looking board. I don't know what size this is. It looks maybe a little bit bigger than ITX, not quite sure. Although it's very much custom for this case. You wouldn't be able to really use this in a normal case because the I/O shield's completely wrong. But yeah, there's the motherboard. Over here we have the power supply, which we'll take a look at. It's quite a nice unit with the power inlet from the back. There's those two noisy fans we'll take a look at. Here's that VGA connector, which goes to a cable to the motherboard. Then over here we have some hard drive mounting, which we'll also take a look at later. So we'll now go in closer and take a look at each sort of area individually. So now here we can see the specs of the power supply, which is just a standard off-the-shelf 12-volt unit. And it just plugs into the motherboard over a sort of standard, almost like EPS 4-pin header here, with just two wires in it. That's how this motherboard gets power. So yeah, that's the power supply there. And all the rest of the voltages are handled by the motherboard. So it's just a standard 12-volt power supply. Now what sold me on this brand of these machines rather than others is that this one specified that they use power supplies made by Meanwell, who are a proper company that make power supplies. You can buy these from many suppliers in the UK, all over the world. They're a reputable brand, they're not some dodgy thing. So that's why I went for this brand, because they specify that they use Meanwell power supplies. Down here we can see the specs. Obviously it's a 12-volt unit, and it's rated at 150 watts, which is absolutely tons. It's way more than this machine would need, but yeah, it's a 150 watt, 12-volt power supply. Down here we can see the mains connections, which it's only one thing just to bear in mind, is that these are exposed. So obviously they're fine if the case is shut, but just if you're working inside one of these, be careful, because it's not like a standard PC where you can open it up and poke everything and not get near mains. These contacts are live at mains voltage when the machine's plugged in, or when it's switched on the back as well, but yeah, you don't want to be poking around with these. Interestingly, some of these power supplies, when you buy them, actually have like a little plastic cover that goes over this, and there's like little holes here where that would mount, so I don't know if it's just gone missing or something. But yeah, just bear in mind, if you're inside this, these terminals are live at mains voltage and you can sort of touch the mains, so yeah. But on the plus side, they're actually proper terminals, so we can unscrew that. And that lifts up, screw comes out, and you can see it's actually a proper little ring terminal, and then it uses the nice little sort of square thing on a screw to mount it. So yeah, even though it's a little bit dodgy being able to touch the mains there, it's all fairly well attached, so you're not, the electrical safety seems reasonable. Just maybe just don't work on it when it's open. It would be my advice. Although they have at least like heat shrink these terminals onto the back of the connector here, which is good. Just those are a bit uncovered, but yeah, that's the power supply. One important thing to bear in mind with this power supply is that on the side here it has a voltage selection switch, which in mine came set to 230 volts. However, if you do get one of these, I would strongly recommend opening it and checking what it's set to, because I looked it up in China, it also uses 200-ish volts. So I don't know if they set that to their voltage and then ship it to you, or if they actually work out what country it's going to and set it to the correct voltage. So there's always a risk if you bought this and tried to use it in the US, you would get it set to the wrong voltage. So yeah, I would definitely just pop it open and just check what this is set to and adjust it if required before you actually use it. So now over here we have the motherboard. So what I'll do is I'll disconnect all the wires and actually take the board out so we can take a nice close-up look at it. Okay, so I've now removed the motherboard from the case, so let's take a look at it. It was just held in with 4 screws, nothing that fancy, although interestingly each screw had like a little red insulating washer on it, which doesn't really make much sense because surely the screw's meant to sort of ground the board to the case. I thought that was always how it worked because you had the little metal pads around the screw, but yeah, they had those washers. I'll put them back in just to have it exactly how it was from the factory because there might be a reason for it, but yeah, bit interesting, but whatever, doesn't really matter. Let's take a look at the board. So on the front here we can see those ports, and then there's those 2 buttons that were hidden inside the case before. It's fairly simple. Each port then labelled with like a MAC address and stuff on top. Behind it here you've then got this little heatsink. This heatsink has all the Intel network chips underneath. And it's actually a proper one. It's properly like fastened on through the bottom. It's not just stuck on, so it should be fairly well held on. So little push pins going in there to hold it. Over here, we can see we have a few different headers. So we have this one here labeled COM2. So this would be for an extra serial port. There's then sort of DC input here, along with a different DC input here, which is actually for like a barrel jack. So they do this machine in a desktop form factor, which doesn't have a built-in power supply. So imagine in those machines what they'll do is they'll have a hole in the side of the case and then give you an external power brick that we plug into here. Over here you then also get this header, which is labelled LAN LED. So there must be some way you could probably plug like a bunch of LEDs into that and have it work off the Ethernet ports. It doesn't really matter because these all do have LEDs built in. Although I suppose it could be useful if it was a case where these are on the back and you wanted LEDs on the other side of the machine. So yeah, those are there. There's also this area here, which would be for a PCI riser or PCI Express riser. Although these aren't they don't seem to be like properly plated, they're just sort of soldered. They're just solder on there really. And there's a missing chip here, so I don't think that is actually populated on this machine, so it probably wouldn't work. But yeah, that's that there. So now let's take a look at this area of the board. So you've got a BIOS chip here. It's made by Winbond, so I'm pretty sure that's the BIOS. Little PC speaker. You then get 4 SATA ports, as well as 2 USB headers. You get 3 fan headers, one which is used by the internal CPU fan, and the other 2 which are used up by the case fans. This is like a debug header, so you probably wouldn't really use that. There's then this here, which is actually a GPIO header. So there's not much documentation on this board I can find. The link on the manufacturer's website is dead, so I can't find, the manual won't load. But you could probably figure out how to do the GPIO there. This is a front panel header, so if you had a case with a separate front panel, you would use that. Then what you've got is you've got these 2, which are power outputs. These are used for SATA hard drives, so we'll look at how the drive mounting works later, but that's what those are for. Then you have a compact flash slot, so you can actually use compact flash cards with this. This is all powered by this chip here, which is an IDE to SATA bridge, because a compact flash card is effectively an IDE drive, so this will bridge that over to the SATA bus in this machine, which is quite good, so it does do it over proper SATA and not some sort of horrible USB thing. So there is a compact flash slot if you needed it. There's then this header labelled print, which is obviously a parallel port header. We then have the Super I/O chip here, and that is the header that connects the VGA port on the back of the machine. And then finally, we then have just a CMOS battery over here, which is obviously the reason that they couldn't actually ship it using EMS. They had to use DHL. So now let's take a look at the other bits we have on here. So we have the stick of RAM, let's see what we get here. So obviously it's got 4 gigs of RAM, so let's see what we have. Crucial. So you're actually getting what looks like a proper genuine Crucial stick. I suppose it might not be, but I mean it looks completely genuine. The chips have the Micron logo on it. So yeah, I think that's actually a genuine Crucial stick of RAM, which is impressive. I was expecting them to just use the cheapest stick they had, just buy RAM in bulk, but yeah, it's actually a Crucial stick of RAM. And it is a 1.35 volt, 1600 megahertz chip. So it's DDR3L, 1600 megahertz, 4 gig. So yeah, that's actually pretty decent RAM. And now finally, let's take a look at the SSD we get. So actually the other thing is these ports. So you get these 2 slots here. This one's labelled Mini SATA, so that's got the Mini SATA SSD in it. It's not M.2 or anything, but you get a Mini SATA slot for the SSD. And then this here is Mini PCIe, so you could use a Wi-Fi card in here potentially, or any sort of other card that would fit into this slot. And then there's a screw there for it included. Interestingly down here, there's these sort of pads, which would be actually for a SIM card slot. Unfortunately, this machine doesn't have that populated, but if you could get the board with that, which I think they sell separately, you could put a SIM card in there and use a 3G modem. However, unfortunately, that's not populated, so you probably couldn't use that. But yeah, that's what we have. So we'll take the SSD out, so just a single screw on the side here, and we can take a look at what SSD it is. I'm interested to see what sort of chipset it is. Okay, so here we can see the SSD, so let's take a closer look at it. It's just branded by them, so it'll be interesting to see what it uses in terms of flash and a controller. So now here we have the SSD. So I did a test of the performance of this, and it's pretty meh. It's nothing fancy at all. So here you can see the results I did from Crystal Disk Mark. Yes, I did actually install Windows on this to test, and it can read at 188 megabytes a second and write at about 40 megabytes a second when you're doing a sequential write. So it's a pretty sluggish disk, but it's not here as a performance drive, it's purely to boot PFSense. So as long as you're using this in a standard use case, like just using it as a router, you don't need a much better SSD than this. This is absolutely fine. So on the front, we can see it's branded by them, and it's labeled 64 gigabyte. They do this SSD in 32, 64, 128, and potentially 256 gig. Actually, I think they maybe only go up to 128 with this, yeah. But yeah, it's a MSAT SSD, so it's absolutely fine. So on the back, you can see there's a sticker over the flash, which is actually quite cool because obviously these come straight from the factory, and you can see this is labelled May 2017 in terms of the date, which is actually when I bought this machine. I literally bought it at the end of May, or very start of June, so it literally hadn't even been made a month before it arrived. So you can see we've got a single chip on the back, and another one on the front, and then a pair of unpopulated spaces. So my guess would be these are each 32 gig flash chips, so they could put them up to 128 by putting 4 chips in. So what we'll now do is I'm going to break the rule here which says warranty void if lably removed, and I'm going to peel the lably back and we'll see what controller and flash it has. So I'm going to void the warranty by peeling back the misspelled label, and we'll see what we get. Let's see, it's relatively careful, don't want to completely destroy the look of it, but I'm interested to see what they use here. So the first thing we're going to see here is the controller. So that's the controller there. Little chip. See if we can get a part number off of it. It is a SM2244LT. So that's a chip. I'll try and find a datasheet and put it up, but yeah, that is the controllers they're using for the SSD. So put the label back down, and now we'll see what flash it has. So we'll look at this chip here, hopefully, see what we get. Peel that back. Okay, interesting. So it's actually using Intel flash. So you can see here, there's a little eye on it, so that's the Intel logo. And yeah, it's a little Intel flash chip. So let's see if we can get a model off of that. It is a 29F32808JC, is it? JCM-E2. So that's the flash there. And it's copyright 2009, so that's probably why it's quite slow. It's just a very outdated flash chip. But on the plus side, it's Intel flash, so it might at least be reasonable quality in terms of like life expectancy. So yeah, that's the SSD. Not the sort of thing I would be buying to put in like a laptop or anything, but for this sort of purpose, it's absolutely fine. Okay, so that's a look at the motherboard, and it actually seems like a pretty nicely built device. It's, you know, reasonably laid out, has a load of functionality on it, especially in terms of the optional headers that you have, and yeah, it feels pretty decent. Also interestingly, despite the listing saying that it uses an Intel NM70 chipset, this actually uses the higher end HM65 chipset, which is fairly old. It's a sort of Sandy Bridge laptop chipset, but it actually has quite a lot of functionality. So you've got a fairly old chipset and CPU, but for this it's absolutely fine. And I'm guessing that's how they can just do it so cheap, as they use slightly outdated processors that they're probably able to buy from suppliers that are wanting to shift the stock. So yeah, that's a little board. And yeah, it's a pretty nice little built board. So what we'll now do is we'll put this back in the case and take a look at the drive mounting. Usefully, this machine also allows you to mount a single 3.5-inch drive or a pair of 2.5-inch drives. So let's take a look at how that works. So down here, we have this little metal plate that's installed with 4 screws. So what we need to do is take those screws out to remove the plate. You then mount the drives to the plate and then mount the plate back into the machine. So it's pretty simple. So let's take a look at how that works. So now here we have the plate. So that's it there. And then if you wanted to install a drive, if you install a 3.5-inch drive, which we'll do first, you then line up the bottom and put the screws in. Now you need to make sure you get it the right way around, because the holes for these screws aren't quite in the centre of this. So if you mount the drive this way, what happens is the screws that you need to use to mount the plate to the case are actually covered by the drive. So you need to make sure you then mount the drive the other way around, because if you do that, then the screws here and the screws here are available, so you can actually do it. So what we now need to do is put the 4 screws into the drive and then mount the plate back into the case. Okay, so now those screws are in, the drive is now mounted in the caddy, so all we need to do is screw this back into the case and connect the drive up. Okay, so the drive is now installed in the case and it's very solidly mounted in there, which is good. Of course, bear in mind that there's no shock mounting on this, so if you've got a really loud hard drive like this one would be, it will rattle the whole case, so it might be a bit noisy. So you'd probably be better off with SSDs in this case, but yep, that's the hard drive mounted. And now let's connect it up. So in the bag you get a power cable for it, as well as a SATA cable. So I'll just show how all this connects up. So SATA cable obviously just plugs into the drive, and then plugs into the motherboard somewhere. You could probably find a nicer way to route it. You could possibly like route the cable under the drive or something like that, but yep, the cable just sort of mounts in there somewhere. And there does seem to be just about enough clearance on top of that. And then for power, what you do is you get this SATA power connection. So this end plugs into the back of the drive, like that. And then the other end of this plugs into one of these two headers here on the board. So just plug it in there. And there you go, that's that hard drive now connected up to the motherboard. So what we'll now do is we'll take all this out and look at how you mount 2.5-inch drives. So now let's see how we mount 2.5-inch drives. So for that I'll be mounting these two SSDs. So we have the same bracket as before. However, whereas the hard drive is mounted with it sort of facing, with like the U shape facing up, you can't do that with 2.5-inch drives, because what will happen is the U shape will block the connectors on the drive off. So instead what you need to do is rotate this the other way up, and then you just place the drive on and screw it in from the bottom. So we'll go and do that, and then we'll mount it in the machine. Okay, so that's the SSDs now mounted in the bracket. They're again fairly secure. I've only used 2 screws on each just because that's what I had. Obviously there's space for 4. And we can now look at how this goes into the case. So, same as before with the hard drives really. You just drop that down and then you can just screw it in. Okay, so the SSDs are now mounted. So, this is where you'll find a slight flaw. So if we go to plug these in, first of all you do only get one set of cables. But if you plug this one in, that goes in absolutely fine. And then we just pop that onto there. Of course, if you were doing this properly, we'd run the cables a bit neater, not over the fan, but it's just an example. I'm not actually going to use drives in this machine. So you just plug it in like that, and that is absolutely fine. However, there's a problem when you want to connect this one up, because there's these connectors here, and that doesn't leave enough space for this SATA power plug or the SATA data connector to fit in without hitting off these connectors. And then you couldn't really mount the drives the other way around either, because then it'll hit off the side of the case. So if you want to mount a single 3.5-inch drive or a single 2.5-inch drive, you're absolutely fine. If you want to mount two 2.5-inch drives, you would probably need to look into getting some sort of, like, you would need to get additional cables anyway. But you'd probably need to look into like getting a right angled cable or something, because I imagine if you had a pair of right angled connectors that were bent in the correct way, you could just have the cables point up from here and it would be absolutely fine. So it's just something to bear in mind if you're wanting to do that, because it can fit the two drives, but you need to get special cables to fit this one. So that was a look at the hard drive mounting, which is a pretty good thing to have in this. Obviously it's not the sort of thing you'd use as a storage server or a NAS, and you wouldn't use it like as a big production server either. But I suppose something like this could be quite handy if you wanted to either like have some sort of cache on your router or use it for like storing loads of logs. You could have a hard drive in it. So there's definitely use cases where you would want a hard drive in a device like this. So yeah, it's pretty nice to have that functionality. Even if it is a case that if you want to mount two 2.5-inch drives, you need to sort of bodge the cables a little bit. But yeah, for a single drive, it's absolutely fine as well. Another accessory that came in the box was this cable here, which in theory is a really nice idea. It's just a standard DB9 serial port in the same form factor as the VGA one. So the idea would be, if you're building a device that's potentially some sort of appliance where you don't want people plugging a monitor into it, or you know your software is built more for a serial console than a monitor, you could use this instead. So you could unscrew the retaining clips on the retaining screws on the VGA port, take it out and mount this instead. However, unfortunately, they've obviously, I think they must have just included the wrong one with this, because first of all, this cable doesn't actually reach over to the COM2 header over here. And second of all, the COM2 header is actually a different sort of pin pitch from this. So I suppose you could potentially modify this, but it's not really worth it, it's just not long enough. However, it does sort of give the idea of what you could do, and it is relatively inexpensive to buy these sort of cables with these serial ports. So assuming you can find one that's long enough and uses the correct header, you could fairly easily replace this VGA port with a DB9 serial port. So it's a very nice idea. It's just a shame the cable they give you doesn't actually fit the machine. Oh well. So the final thing we'll do before we actually fire it up and get it running and do some performance tests is we'll replace these two fans just with the nice quiet Noctuas and see what it does to temperatures. It shouldn't be too big a deal, and hopefully it'll be a lot quieter. So what we'll do is just unscrew these fans, get them out of the case. Interesting to see what they are as well, actually. See if they're actually like proper branded fans or if they're actually cheap rubbish. And then we'll fit the Noctuas. Okay, so the fans are now unscrewed. I'll just unplug them from the main board. Just those two fan headers. And pull them out. So let's see, what are these? Okay, they're actually a proper brand. These are made by Yateloon, who I've actually heard of. They're quite common in power supplies. So it is at least a proper brand of fan. They're just a bit loud. It's not the sort of like the big Sanace or Delta fans you would get in a server to cool like a 1U server. They're more the sort of fans you'd see in like a high-end network switch. So they're a bit higher pressure than things like the Noctuas, the little 40mm consumer PC ones, but they're also quite a lot louder. So they're probably not bad quality fans, they're just a bit too loud for my use case. So I'll hang on to these because they could be useful in another situation. But what I'll do in this machine is I'll install those Noctuas. And I've already done some performance tests with those fans in terms of temperatures, so we'll put the Noctuas in and see what it does in terms of temperature. Hopefully it won't cause too much of an increase. So here I have the two Noctua fans. These are the NF A4X10 FLXs, which are just standard 12 volt fans, and they're really quiet. They weren't particularly cheap, but they're not bad either. I had these left over from a previous project, actually my old router, so a couple of generations ago I used these, and they've just been sort of sitting around ever since, so I may as well chuck them into this. There's no real, it would probably be absolutely fine without the fans as well. However, because I've already got these, I may as well just fit them. So yeah, time to install these fans. So when I install these fans, I'm going to have to use the screws they came with, which unfortunately are silver. That's because these screws are the sort of thick fan type where they sort of actually cut into the plastic to cut a sort of thread into the fan. The fan it came with just used these sort of standard, more normal looking screws, which were black, but which looks a lot nicer, but unfortunately they just wouldn't fit in these fans. So yeah, I'll have to deal with some silver screws on the back, but it's not a big deal. Besides, I'm going to have to look at the colour of these Noctuas anyway through the vents on the back, so having slightly discoloured screws isn't going to be the worst thing in terms of aesthetics on the back. But yeah, just need to mount these two fans, screw them in, and see what they sound like. Okay, so I've screwed those fans in, and now we'll just connect them up. So these two cables shouldn't be too long, should be fine. And then plug one into that header there, and the other into that header there. And yeah, that's actually pretty neat. So all we now need to do, let's put the top back on, fire it up, and see what it sounds like. Okay, so that's the new Noctua fans installed, and I've reassembled the machine. So let's fire it up and see what it sounds like, and then we'll compare it to the old one. Guess who forgot to put the RAM in? Oh god. Anyway, I'll need to take that apart and put that back in. But ignoring the fact there's no RAM in there, that sounds a bit quieter. There's still an obvious noise there, but it's not really any problem. It's definitely a lot better than before. So yeah, we'll put the RAM back in and then see if it actually works. How did I forget that? Arrgh. Okay, so I've now actually installed the RAM, and we'll see if it works now. And that's actually posting this time. Good. So what we'll now do is get this all configured, install it in my rack, and then do some performance tests on it. Okay, so I've now installed the router in my rack, and as you can see, I've configured the ports. So the first port is a WAN port, which goes through the switch directly to my modem on its own VLAN. The last port is labelled management. That's effectively a port I can just plug like any device in, just a laptop or whatever, and get a DHCP IP address allowing me to manage the router if something goes wrong. Then the middle 4 ports are in a lag, so they're in a link aggregated group to give me 4 gigabit of aggregated capacity. This is quite important for me because I've got a lot of things on different VLANs. So for example, if I want to connect my desktop or laptop to my server, it has to go through the router. So that can act as a bit of a bottleneck if it just had a single gigabit link. So having that lag there gives the ability to have a lot more traffic going through it, which is pretty cool. So the next thing is going to be hook up a laptop in on IPerf and see sort of what throughput we can get through this router. See if it can do full gigabit speeds. So for the first test, I have IPerf running on my server in just standard TCP mode, and then I have IPerf the client on my laptop. The laptop's plugged directly into the switch, and I'll be accessing the server, which is on a separate subnet from the one the laptop's on. So the traffic to and from the server has to go via the router. So we'll run this and see what sort of throughput we get. So that's it running. See if we can actually get the full gigabit speed. And yep, that has worked. As you can see, we have got a full bandwidth of 911 megabits a second. So that is effectively the full gigabit speed. So that's great. So the router can definitely do that. This test will test the link aggregated group that I've set up between the router and the switch. What I'm going to do is perform 2 IPerf tests concurrently. One will go from my laptop to the server as before, and the other one will go from the server back to my laptop. Because Ethernet is full duplex, the link between my laptop and the switch and the server and the switch will not be saturated, as it will be able to pass full gigabit speed in both directions. However, if the router had been connected with a single Ethernet cable, that would become saturated and you'd only get 500 megabit throughput, because the traffic from both tests would have to pass both directions on the cable. They'd have to pass in and out. So that would slow it all down. So if the link aggregated group is working, I should still be able to get the full gigabit speed in both directions, because all those 4 cables are grouped together into one interface, so all the traffic should be able to be passed without any problems. So we can see over here, we have the 2 servers running, this one on the server, this one on the laptop, and here are the 2 clients, top one on the server, bottom one on the laptop. So all I'm going to do is start each of these in quick succession. So that's both tests running, and we'll see what sort of throughput we get when they finish. And as you can see, it's worked. So we can see here that the test that was going from the server to the laptop went at 856 megabits a second, and the test from the laptop to the server went at 845 megabits a second. So it's ever so slightly slower, but that's just potentially just other factors. And that shows, or it could be the router sort of maxing out at that point, but it shows that the router can basically manage 2 full gigabit streams in 2 directions over that lag. So that's great. So yeah, the actual performance throughput on this, especially just doing IPerf, is actually pretty impressive. So there you have it. That was a look at this relatively inexpensive 1U server from Aliexpress. And I'm actually very happy with it. It seems reasonably well made, it looks quite nice, it's perfectly powerful enough for what I need it to do, and it was very well priced. I've had it running here a couple of months now and I've not had any problems. I'm not sure if I would trust it in like an enterprise environment or anything mission critical, just because you don't know what sort of tolerances there are on parts and whether it could fail or not. But for a home router like this, it works absolutely brilliantly. So yeah, thank you very much for watching.